So real quick question for you. I've already been reviewing this a little bit, but tell me what's happening here. First of all, you're all too young to have seen John Travolta in Saturday Night Fever, I think it was, or Staying Alive, one of the two. I didn't see it myself, but look at these fancy, crazy pants from the 70s. I mean, it was a memorable kind of scene from back then. So he had this pose that he would strike during his dances. And yeah, you all know who John Travolta is, right? He's been in the news with Scientology and so forth. Yeah. Anyway, that was kind of a pose. So I think of this as the end behavior, the opposite end behavior for those odd polynomials. And then when I think of like quadrilaterals or quartics, I think of it having either a touchdown behavior or an Incredible Hulk behavior. Okay, same thing's happening on both sides. Either they're both going up, both right and left, or both going down. So sometimes having a visual to put with these things, something silly, helps you remember it. So if we're looking at this first one, first of all, is it written in standard form? Yes. Is it a polynomial? Yes. Okay, so what's going to happen on the right-hand side? Going to be positive. Okay, so on the right-hand side, going in the positive direction. What's happening on the left-hand side? Opposite, right? This is a John Travolta. It's going this way because it's an odd. So they have opposite behaviors on each side. Okay, so as x gets bigger, as x goes to infinity, what's happening to y? Y is going to positive infinity as well, right? Is everybody okay with that? As x gets really, really large, y is going to get really, really large. What happens as x goes to negative infinity? As x goes this way, what's happening to y? You told me it's going down, so which way is it going? To positive infinity or negative infinity? When we think about a graph, this is 0, we're counting to 1, 2, 73 miles down the road, we might actually approach a number close to infinity, right? Never will, because we can always add one more, right? -1, -2, 287 miles down the road, if we keep that paper going, we might actually get to negative infinity someday, right? Okay, when the paper was really, really tall, here's 1, 2, eventually it might become positive infinity at the top. What's happening down here as I get really, really far in the downward direction? Negative infinity that way, right? Okay, so as x is going to the left, you told me this is going to go like this somehow. So what's y going to approach? Everybody okay with negative infinity there? So y is going to negative infinity. As x goes to negative infinity, y is going to negative infinity as well. For this equation only, specifically, yep. It'll be different for this one. Okay? Because what's happening here? Is it a polynomial? Yes. Is it in standard form? Yes. So what's my leading coefficient? -2. So what's happening on the right-hand side? It's going down. Okay. What's happening on the left-hand side? Going to the same direction, right? Going down. Also going down because it's an even power. It's the Hulk look to this graph. Okay, so as x is going to the, as x goes to positive infinity, as x gets really, really large, y is going to negative infinity. It's falling on the right-hand side. And as x goes to negative infinity, as it goes to the left, on the left-hand side, y is also falling. So it's going to negative infinity. Yes. So would that be, I'm sorry. Exactly. The end behavior, this is the formal way of saying it. Eventually, yes. For your tests, that's what we're looking for. Okay? I'm cool with you saying it's rising on the right and falling on the left. Rising on the right, or falling on the right, falling on the left. But eventually we've got to get to the point where we can write that notation. If the right was going down, the left's going down as well. Yep. Exactly. Absolutely. Yep. If it's even, they're the same. Copies the right. If it's odd, it does the opposite. Very good. Okay. All right. So let's talk about a couple quick questions. Can we add 5x and 2x squared? No. Why not? Not like terms. We can't combine like terms. We can't add them unless they're like terms. Can we multiply 5x and 2x squared? Yeah. Yeah. We can get 10x to the third, right? All right. So we're going to try to find the sum of these guys. And this is number 1 on your sheet, on your notes sheet. Okay. So we have 2x to the third plus x squared minus 3x plus 4. And we're adding the polynomial x cubed plus 7x squared minus 2. So what are we going to do? Here's what I would recommend. Absolutely. I'm sorry. Here's what I would recommend. When I see a plus sign in between, I'm going to put a plus out here. And then I'm going to drop everybody right below their term. Okay, their like term. So I'm going to put my x cubed here, my 7x squared here. I'm going to make sure I don't lose any signs. And my negative 2, where does it go? Under the 4. Now I'm going to add them up. Okay. So when I add 2x cubed and x cubed, what do I get? 3x cubed. We're adding so we don't do anything with the power. They're just like terms. Add them up. Keep the exponent the same. What about x squared plus 7x squared? 8x squared, because there's an understood 1 here. Negative 3x doesn't have anybody to add to it, so we just write minus 3x. And when I add 4 and negative 2, I get positive 2 plus 2. Okay? Easy enough, right? Been doing work like this before. All right. So now we're going to skip down and look at number 5. So you'll have 2, 3, and 4 to work on your own. Number 5 says to find the difference. Okay, 2 parentheses here again, 2 polynomials. This time we're subtracting. So what do you have to be careful of? The signs, absolutely. So what I would like to do, recommend that you do, is I would say change the sign of every single one of those and write them right below their like term. So a positive 3x cubed is going to become a negative 3x cubed right below the 5x cubed because they're like terms. Positive 5x squared, when it's subtracted, is going to be a negative 5x squared. What's the negative x going to become? Positive x. So we're subtracting, so we're going to change the sign of every single term. And then the 8, negative, good. Now we're back to what we just did. We're adding them up because we changed the sign of every single one of these and wrote them right below their terms, their like terms. So 5x cubed minus 3x cubed, 2x cubed. Negative 4x squared and a negative 5x squared. Negative 9x squared. We just add the numbers. They're both negative. Give them the negative sign. The x squared stays the same. Negative 3x and a positive x. Minus 2x. Positive 1 and negative 8. Negative 7. Any questions on those? Okay. You're careful and write it right below it with all the sign changes, and then be careful when you're adding and so forth. You'll be in good shape. All right, 9 and 10 are about finding products. We're multiplying. We're going to use boxes for these if you like them. If you don't, you can distribute, but you have to make sure you distribute everybody. Okay? So if you want to use the distributive method, I would recommend putting the x minus 2 out in front and put the 2x squared minus 3x plus 5 here. I'll show you both ways. But you have to, it's not FOIL because we have a middle term now. There's no m in the word FOIL. So we distribute the x to everybody, and then we distribute the negative 2 to everybody, and we combine our like terms. But let's do the FOIL box, what we would call the FOIL boxes, but we're going to do the product boxes now and first. And then I'll show you they work the same. So product boxes, we want to have a 2x squared, a minus 3x, and a plus 5. And then we need an x and a minus 2. So we'll draw our box here. I tried to give you room on the worksheet so that you can draw those in. And then we take x times 2x squared. And what do we get? I'll give you a chance to draw your box. You'll get 2x cubed. Very good. Because we're multiplying now, we multiply the numbers, the coefficients, and then add the powers. Okay? X times a negative 3x. Negative 3x squared. Excellent. X times 5. 5x. Now we take our negative 2 times our 2x squared. Negative 4x squared. Negative 2 times negative 3x. Positive 6x. Good. Bless you. Negative 2 times a positive 5. Negative 10. Now we're not done. We have our multiplication done, but now we're just ready to add our like terms. And notice that they're kind of diagonal from each other. So we'll write our first term. We only have 2x cubed. There's nothing to add to it. Okay. Negative 3x squared and the negative 4x squared is a total of negative 7. Good. We didn't change the power, right? We're only adding, we're combining like terms now, so we're not going to change the power. We did that when we multiply. Okay? A 5x and a 6x, 11x, and a negative 10 has nothing to add to it, so it's negative 10. Okay? So that's a product box. You put the terms on the one side, the trinomial on the first side, the binomial on the second side. If you had done it the opposite way, that's okay. Multiply and then add. If you decide to do it the opposite way or the other way, which would be similar to FOIL, but we don't have a middle term, you have to make sure that you multiply x by everybody. 2x cubed, negative 3x squared, plus 5x. And then I recommend when you do the next bumps to make sure that you line them up so that they're all in a row with their like terms. Negative 2 times 2x squared, right up below the negative 3x squared. Negative 2 times negative 3x, and then negative 2 times 5. You get the same result. It's just that this kind of helps you figure out if you made a mistake, because if the diagonals aren't adding up, something didn't multiply right. Okay. Okay, everybody good with that one? We'll work another one together. Decide whether you're using the product boxes or if you're using distributive property. And I'll let you try this one and then I'll work it out. This is number 10. Everybody get 2y cubed plus 12y squared minus 29y plus 24. Okay. All right. So let's look ahead at number 13. Sorry, 13. Okay. What happens if we've got two, not two, but three trinomials, and we're multiplying them together? I might have done this in Algebra 1, way back when. Anybody have a suggestion or an idea? Okay, same thing we've been doing. So let's multiply these two together first, and then when we're all done with that, we'll multiply the last one by it. So let's make a FOIL box here, or a product box. And again, it doesn't matter which way you go with your dimensions, you're going to get the same result. So we'll get a 2x squared and a 6x, and then an x and a 3. So the first two binomials times each other ended up with a 2x squared. Here are my like terms, so 7x plus 3. Now what do I have to do with that? Yep, multiply it by the 2x minus 3. So we can, again, make our rectangular product box. And we're back to a problem just like we just worked. So 2x times 2x squared, 4x cubed, 2x times 7x, 14x squared, 2x times 3, 6x. And then we're going to take our negative 3 times 2x squared. Good. Negative 3 times 7x, negative 21x, and then negative 3 times positive 3, negative 9. Now we're going to add up our diagonals. We'll have a 4x cubed. There's nothing to add to it. Negative 6x squared and a positive 14x squared, 8x squared, a negative 21x and a positive 6x, negative 15x, and lastly our negative 9 doesn't have anybody to add up. There's our result. Okay. Last one. We'll look at number 16 together. AB plus 2 cubed. What does that mean? AB plus 2 times AB plus 2 times what? AB plus 2. Don't let it trick you. It is not a squared b squared plus, or a cubed b cubed plus 8. Okay, that'll be the first term and the last term, but you'll lose all the middle stuff in between. Okay. So AB plus 2 times AB plus 2. When I take AB times AB, what am I going to get? A times A is A squared, B times B is B squared, right? AB times 2. It's 2AB. So 2 times the 1 in front of AB gets us 2, and then AB. And then again, 2 times AB, 2AB again, and 2 times 2, 4. So our net result was A squared B squared, 2AB plus 2AB, 4AB. We're adding now, we're just combining like terms, and then a 4. So we're almost done. We just have to do it one more time. So take it times AB plus 2. Okay. So finish this sheet. If you have questions, see me before school, advisement, or after school.